So 2.5 is transformational functions. And so we have 6 basic functions that we have to, that we will give an account for. The first one is x, y equal to x, gives us this linear graph. Then we have x squared, which is the parabola, x cubed, cubic equation. Then you see we have the square root of x, cube root of x, and absolute value of x. So I'll give you a chance to write those down before we scroll down. All right. So now in this section, we dealt with graphing before. So as far as graphing, I don't spend a lot of time in this section. Basically, you talk about the transformations. You have your summary on page 291, where you can look at the differences and what transpired. All you have to do is pull out a graphing tool. If you don't have one, Google graphing calculator or graphing tool, and you can always put that information inside and see what graph corresponds to the function that you're looking at. So there will be a difference between having, let's let x squared be our basic function. If you have the +1 inside of your square versus the +1 on the outside of the square versus it being -1. So whether it shifts up, down, left, or right, all of those will make that difference. So you just go to the summary if you want to know all of those transformations and those functions for those functions, all the shifts. If you have any questions, always feel free to ask. But for the most part, you can get a graphing tool and look at those transformations.
Can you scroll up just a little bit?
Right.
Oh, okay, I got it. Thank you.
Yep, not a problem. Questions on what I was saying about 2.5. So, like I said, check them out. They will be asking about shifts and everything like that. You can always, like I said, throw it into a graphing tool. I'm not going to ask you much outside of that other than what shifts occur. You should have that graphing tool available to you, when you do your test. And my math lab will give you the function, give you A, B, C, or D, which function is this assigned to this graph, or some along those lines of what they will ask. And you'll go from there. All right. Questions before we look at 2.6? All right, so 2.6. Finding, we're looking at combinations of functions and composite functions. All right, so we're looking at finding the domain. So you want to look for all the values that can be used for x. Or in other words, all values that can be plugged into the equation for x. So to find the values that can be used, look for the values that cannot be used. All right, so for the first one, find the domain of each. They give us, for our function, x squared minus 7x. So basically what you're going to do is come into the function looking for pre-existing conditions that will make your function undefined. And so you'll see what I mean as we talk about it and get to the next one, most definitely. But you want to ask yourself, is there a value that can be plugged in for x that will make the equation undefined? In other words, once again, you're looking at this function to say, is there ever a situation where I can plug this in, plug something into x and make it undefined? Is there anything that can make a quadratic equation, a parabola, undefined? So the answer is no. And like I said, you'll see in the next one what I mean by a pre-existing condition. So the domain is anything. You can plug in anything. So we're talking about negative infinity to positive infinity. There's nothing that you can plug into this function right here to make it undefined. So everything you plug in, if you plug in positive 1, you will get a number out. If you plug in negative 1, you get a number out. If you plug in 0, you will get a number out. So you can calculate any value that you plug into this function. So your domain will be negative infinity to positive infinity. Mm-hmm. Scroll up. All right. So the next one, and this is what I talk about, or this is what I mean when I say a pre-existing condition. Here we have a fraction. We have g of x is equal to 2 over x minus 5. Can you make this fraction undefined? The answer is yes. Fractions are undefined when the denominator is 0. So that's what we're talking about, a pre-existing condition. The pre-existing condition for fractions is that when the denominator is 0, the function is undefined. And I say fraction, I use that loosely, fraction or rational expression. So the pre-existing condition for a rational expression is when when the denominator 0 is undefined. All right. So whenever you have a rational expression, you're going to set your denominator equal to 0 and solve it. So our denominator was x minus 5, set it equal to 0, solve, we have x equal to 5. And this is the value that cannot be used. If I would have put 5 in that denominator, I would get 0. Once again, that is the value that cannot be used. So my domain will go from negative infinity to 5. Use parentheses. That means you can get as close to 5 as you want, but not use 5. So it'll go from negative infinity to 5, then 5 to infinity. Questions. right. Next one, we have 3x plus 2 over x squared minus 2x minus 3. Once again, we have a rational expression, so we'll set the denominator equal to 0 and then solve. So set x squared minus 2x minus 3 equal to 0. And solve x minus 3, x plus 1 is a factorization. Set each piece equal to 0. You get x equal to 3 and x equal to negative 1. And once again, those are the values that you cannot use. That's when your denominator is equal to 0. All right, so to cover all the values that can be used, you go from negative infinity to negative 1, negative 1 to 3, 3 to positive infinity. All right, questions, any questions? Everybody okay? Okay, the next one, we have the square root of 3x plus 12. So once again, you want to ask yourself, can you make this expression undefined, or when is this radical undefined? So you cannot take the square root of a negative number. And we talked about whenever you take the square root of a negative, your answer will be imaginary. So we cannot take the square root of a negative number. And here I was just notating that what's under the radical is called the radicand. 3x plus 12 would be considered your radicand. All right. So in order to find the domain, you want to know when is the radicand greater than or equal to 0. So you take 3x plus 12, set it greater than or equal to 0. And you say equal to, because remember, you can't take the square root of 0. Square root of 0 is 0. So you would subtract 12 from both sides and divide by 3. All right. And so since we have x is greater than or equal to negative 4, that means our domain goes from negative 4 to infinity. And don't forget, it's the or equal to, so this time we use bracket because we can use the negative 4. right, questions? Any questions? All right, here we have the algebra functions. This is basically adding your functions, short notation for adding your functions, subtracting your functions, multiplying and dividing your functions. All right. So basically just saying if you see f plus g of x, you're going to add those functions, f minus g of x, subtract them, multiply, and divide. So next exercise, they define f of x as being 2x minus 1. G of x is equal to x squared plus x minus 2. And he wants to find each. So the first one, f plus g of x, we'll add our two functions together, 2x minus 1 plus x squared plus x minus 2. So all you would do is combine your like terms. 2x plus x give you 3x, and then -1 and -2 gives you that -3. Of course, you couldn't add x squared to anything. All right. Do the same thing for subtraction. Distribute the negative. We have 2x minus 1 minus the quantity of x squared plus x minus 2. So we'll distribute our negative into that g function. That'll give us negative x squared minus x plus 2. And then from there, combine our like terms. That'll leave us with x squared, negative x squared, plus x, and plus 1. All right. F times g of x, multiply your functions. 2x minus 1 times x squared plus x minus 2. So 2x times x squared, 2x cubed, 2x times x, 2x squared. 2x times -2 is -4x. Then multiply -1 to each term, which will give you negative x squared, negative x, and plus 2. Combine your like terms. Add your 2x squared and your negative x squared. Negative 4x and negative 1x. And you will have your most simplified expression.
Sorry, can you go back a little bit?
Is that what you need, or further up? Or?
Yeah, that's good. Okay, I got it. Thank you.
Mm-hmm. questions? All right, last one like this. Put f of x over g of x. And, if you can reduce, you are expected to do so. If not, then you just leave it as is. In this case, there's nothing that could be reduced. And so that would just be it. Questions? Any questions? All right. Oh, and this last one, I just went ahead and said that if you had a 2 here instead of x, then all that means that you would take 2 and plug it in wherever you see x. So that's what we did here. If I had f of g of 2, so I took 2 and plug it in right here into this function. So that's why you have 2 times 2 minus 1 over 2 squared plus 2 minus 2. Then if you simplify, 4 minus 1, 4 plus 2 minus 2, so that'll give you 3/4. That's a final answer. All right, any questions? All right. All right, so the composition of functions. We have fog, or what we call fog of x, and gof of x, wherein all it means is that you're going to take the function that comes second and plug it into the original function. So that little circle right here, you would see in your notation, and that just means your composition of your functions. And make sure you're careful with your order, because the one that comes second get plugged into the one that comes first, that came first. So fog of x is not going to give you the same thing when you do gof of x. All right. So if they give us the two functions, f of x is 3x minus 4, g of x is x squared minus 2x plus 6. And they want us to first find fog of x. That means I'm going to take this g function. Hold on. Oh. All right. Sorry about that. Have my eraser on. So we're going to take this function of g and plug it into f of x. So that's what we did here, where I saw x. So where I saw x, I plug in g. So that's why you see 3 times x squared minus 2x plus 6. And that minus 4 is still back there. All right, then you have to distribute. Distribute the 3, that'll be 3x squared minus 6x plus 18. Then add the 18 and the negative 4 in the back. And that'll give you 3x squared minus 6x plus 14. So we took G and we plugged it into F. Questions? Any questions? All right, so for the next one, it wants to find golf of x. So that means we're going to take F and plug it in both places of x where in our G function. Let me see something, make sure I didn't leave something out. Okay. So that's what we did here. We had x squared minus 2x plus 6. That was our G function. So each place that we saw x, we put 3x minus 4. So 3x minus 4 right here, 3x minus 4 right here. So then we distribute that negative 2. And also, don't forget here, it's 3x minus 4 squared. So I did that work over here. You cannot just square the 3x and the 4. You have to, expand that out. It's 3x minus 4 times 3x minus 4. So you have to FOIL that out. Get rid of this. All right, so FOILing out 3x minus 4 times 3x minus 4 will give you 9x squared minus 24x plus 16. Distribute the negative 2, that'll be negative 6x plus 8, and then you still have the plus 6 in the back. From there, combine your like terms. Negative 24x and negative 6x gives you negative 30x. And then 16 plus 8 plus 4, 16 plus 8 plus 6, gives you 30. All right, questions? Any questions? All right. So the next one, instead of having golf of x, they give us golf of 1. So just like I did in the previous example, when we were talking about plugging in 1, last time we had a 2, this time we're plugging in 1 in for x. So you can handle this one of two ways. So one way is if you have golf of 1, you could take 1 and plug it into f, because remember what it represented. Golf of 1 means golf of f, golf of x means golf of f of x. So you take that 1 and substitute it in for x. So that means we translate that. That means the first thing we will look at is the function of f, and we plug in 1 into it. And that's what I have right here, f of 1. So it's 3 times 1 minus 4, which will give you -1. So f of 1 is equal to -1. So now you take -1 and plug it into G, and that'll give you 9. So that's one way of doing it. All right. The other way is recognizing that since we did this, we can take 1 and plug it into that function right there, that 9x squared minus 30x plus 3, and plus 30, excuse me. You know, that's the result of G or graph of X. So you just plug in 1 into that result. And when you plug in 1 there, 9 times 1 squared minus 30 times 1 plus 30 would result in 9. So you either way you'll get 9. You just have to make sure you do it correctly. Questions? Any questions? All right, any questions before we start 2.7, excuse me, 2.7? All right. All right, so 2.7 is your inverse functions. You let f and g be two functions such that when you plug g into f, it simplifies and gives you x. Then you plug f into g, it also simplifies to give you x. Then g is the inverse function of f. And then the notation is going to be f inverse of x. All right. Oh, another key to your inverse, the domain of your f, or the domain of your function, is the range of your f, or the inverse function, or the function's inverse, and vice versa. So in other words, your domain and range for the function will be flipped for the inverse of your function. All right. All right, so if we had to show that the functions are inverses of each other, don't forget the key to it is that when you plug g into f, it gives x out. It simplifies to just x. When you plug f into g, it simplifies to just x. And both of those have to occur if they're going to be inverses. Make sure you check both ways, because if you do one, there will be problems wherein if you do one way, it will work out, and then if you do it the other way, it will not. So you do have to check both ways. So first thing we'll do, or first thing I decided to do is take f and plug it into g. Oh, no, let's do this. I think I did g and plugged it into f. So take g and plug it into f. And so that's 3 times x minus 2 over 3 plus 2. 3's cancel. That leaves you with x minus 2 plus 2. 2's cancel and leave you with just x. All right, then the next one, you take 3x plus 2 and then you plug it in to g. So that's what we did right here. 3x plus 2 minus 2 over 3. So there's nothing holding that 2, the parentheses there. So 2 minus 2 cancels, leave you with 3x over 3. 3's cancel and leave you with x. So the fact that they both simplify to just x lets you know that you have inverses. Those are inverse functions. All right, questions, any questions? All right, scroll up. All right, one-to-one functions. If each element in the domain goes to exactly one element in the range and vice versa. So remember a function, each element in the domain goes to exactly one element in the range. Now, one-to-one function means that each element in the domain goes to exactly one element in the range. One element in the range go to exactly one element in the domain, or each element in the range go to exactly one element in the domain. So you can't have any repeated values anywhere. So remember before when we were just talking about regular functions, we had repeated values in a range. We will not have any repeated values in any case when you're talking about one-to-one functions. All right, so if a function is not one-to-one, this is why it's important. If a function is not one-to-one, then it does not have an inverse. So that's why it's important to talk about one-to-one functions. If it's not one-to-one, it does not have an inverse. All right. So the way we'll be able to test, one of the ways we'll be able to test test the one-to-one function, horizontal line test. Same thing as a vertical line test. If the line is horizontal, then that means if it crosses, not the line's horizontal, using the horizontal line test, if you have a horizontal line and it crosses or touches a graph more than once, then it is not one-to-one. So looking at these three, looking at our linear equation, this is y equal to x, it's y equal to x squared, y equal to x cubed. So your linear equation is a one-to-one function. Your quadratic X squared gives you that parabola. It's not one-to-one, but it's still a function, just not one-to-one function. Excuse me, because remember we decided or found out that it is a function. So it not being one-to-one does not stop it from being a function. It's just not a one-to-one function. And then a cubic equation is one-to-one. All right, so finding the inverse. First, you want to check to see if the function is one-to-one. If it is not, then there is no inverse. So don't waste your time once you establish whether your function is one-to-one or not. If it's not one-to-one, then you don't have to do anything else. You do not have an inverse. If it is one-to-one, then you go ahead and replace f of x with y. Step 3 is interchange x and y. Step 4 is to solve for y. Then step 5 is you're going to replace y with f inverse of x. So I had to come back and replace your notation, put in the proper notation for your last step. All right. So the first one, want to find the inverse of x cubed plus 1.
Sorry, can you go up a little bit?
Mm-hmm. Let me know if I didn't go up far enough.
Okay, that's good.
All right. All right. So we're looking at f of x equal to x cubed plus 1. First thing you want to do, remember the first step is to determine if it is one-to-one or not. So it's a cubic equation. Horizontal line test shows that that is one-to-one. Step 2 is to replace f of x with y. All right. Step 3 is to interchange x and y. So notice we where x was, y is now, and where y was, x is now. And I'll scroll up more in a second, but step 4 is to solve for y. All right, so subtract 1 from both sides. and then take the cube root of both sides in order to get that cube off of y. All right. Once you solve for y, you replace f inverse of x with y. And that'll be solving for your inverse. All right, questions before we do another one. Make sure we're okay with what we did. So if you go those 5 steps, it's always the same process. First of all, you establish if the function is one-to-one. If it is one-to-one, you go ahead and go with the process of taking f of x, plugging in y, interchange x and y, solve for y, and then use that f inverse notation. All right, scroll up. Already done with this one. All right, so the next one, we have f of x is equal to x squared plus 3x minus 5. Once again, the first step, determine if the function is one-to-one. So here we have our quadratic equation. Parabola is not one-to-one. Therefore, there is no inverse. There is no inverse. And so, and here I was just emphasizing why it's important to determine whether your function is one-to-one or not, because your inverse wouldn't pass the vertical line test. You know, right here. When you look at the inverse of your parabola, it wouldn't pass the vertical line test. So since that's the case, then the actual inverse would not be a function at all. So if your function is not one-to-one, that means the inverse would not be a function. So that's why they're saying that there is no inverse whenever your function is not one-to-one. Horizontal line test would actually change into the vertical line test for your inverse. All right. Questions on that one? Got one more, and then we'll be done. Any questions? Scroll up. Are you okay? Okay. So last one for today. F of x is equal to x plus 2 over x minus 3. So we throw that in a graphing tool. This function is one-to-one. That'll be the easiest way to determine whether your function is one-to-one or not. Throw it in a graphing tool and then use the horizontal line test. So once you establish that your function is one-to-one, follow your steps. Step 2, substitute in y for f of x. That's what we did here. Step 3, interchange x and y. So each place that we saw y, we put x. Each place that we saw x, we put y. right, any questions? All right, so now we want to solve for y, but we have to get y out of the denominator first. So we'll multiply both sides by y minus 3. So multiplying both sides by y minus 3, that cancels out the y minus 3 in the denominator. And gives us x times y minus 3 equal to y plus 2. Distribute x. So if you distribute x, you have x times y minus 3x equal to y plus 2. Now your goal should be to get all of your terms with x on one side. I mean, not x, but y, excuse me. All of your terms with y on one side, all of your terms without y to the other. So I will go ahead and subtract xy from both sides and subtract 2 from both sides. So that I have each one of my y terms on this right side and each one of my terms without y on the left side. All right. Reason why we would do that is so that we can factor out y. So I'll pull y out of each term. So that's y times 1 minus x. Divide both sides by 1 minus x. So it'll cancel out over here on the right. So it means y is equal to negative 3x minus 2 over 1 minus x. All right. And then to finish it off, step 5 is to take f inverse of x and plug it in for y. And that's what we did right there in our last step. Questions? Any questions? All right. So as always, try the stuff out, see if any questions are to be generated. Next class, we're only going to do 2.8. That's the last section out of chapter 2. And so if you have any questions, we can always answer those at the end of next class as well. And then after that, we'll also be looking to do a review day. So we got 2.8, which is Wednesday. And then that next Monday would be a review day for us. All right. And so let me see. I haven't talked about how we're going to do this test. I'll establish that next class. Let me take a look at some things first. So we'll talk about how we're going to do the test on next class and go from there. All right. Questions, concerns, comments before we close? Everybody good? Everybody straight? All right. So you guys have a good one. Be safe, and I will see you on Wednesday.
Bye. Have a good day.
Thanks. You do the same.